Stars start off as clouds of gas and dust inside a stellar nebula. These are often called the nursery for stars because it's where they are first formed. Stars are made from very hot gas, and they're two of the lightest gases, hydrogen and helium. Stars shine by burning hydrogen into helium inside their cores, later beginning to create heavier elements. Stars are approximately 90% hydrogen and 10% helium, with trace amounts of other elements. When particles pass through the stellar nebula, it gets pulled in, making the mass of the cloud of gas and dust increase, which initially makes the temperature increase as well. Under the star's own gravity, the cloud begins to compress. When it is compressed, it begins to flatten and turn into a giant disk. In the middle of this disk, there is a more concentrated part that forms a gas sphere. Gravity keeps on pulling in more and more particles until the temperatures get so high and the pressure so intense that fusion can take place. The most common being when hydrogen nuclei collide and form into helium and release massive amounts of energy. And that is when the star is born. This is a nebula. Inside of this, there are stars being made. This is the star formation when it turns into a disk, and you can see in the middle a gas sphere being formed. This is when particles are being pulled in by a protostar, and this is a newly born star, which kind of looks like our sun. And there's a video on star formation.
All you need to make a star is hydrogen, gravity, and time.
Gravity pulls the dust and gas into a giant, swirling vortex.
Gravity brings matter together. And when you bring matter together and you squeeze things into smaller spaces, they necessarily heat up. It's a simple law of chemistry. You compress something, you drive the temperature up.
Over hundreds of thousands of years, the cloud gets thicker and forms a giant, spinning disk bigger than our entire solar system. At its center, gravity crushes the gas into a super dense, super hot ball. Pressure builds until huge jets of gas burst out from the center.
That really shows you how violent a process star formation is. These jets are many light years across. Something is literally accelerating material very fast across unimaginable distances.
Gravity keeps the pressure on, sucking in gas and dust particles that smash into each other, generating more and more heat. Over the next 500,000 years, the young star gets smaller, brighter, and hotter. Temperatures at its core reach 15 million degrees. Only at that mind-boggling temperature can atoms of gas begin to fuse together, releasing massive amounts of energy. And just like that, a star is born.
The energy from stars is produced by nuclear fusion reactions. This requires higher temperatures and pressures in order to occur. Nuclear fusion reactions always make larger atoms out of smaller ones. The most common is hydrogen fusing into helium, which later fuses into heavier atoms, and so on and so forth, until you reach iron. The production of elements through nuclear reactions is called nucleosynthesis. There are different types of nuclear fusion. There's proton-proton fusion, helium fusion, and the carbon fusion cycle. And these are the pictures of each. Proton-proton fusion is the fusion cycle that powers the sun. This occurs when two protons fuse together, making one of the protons be transmuted into a neutron, which is called a deuterium. Then the deuterium fuses with yet another proton, resulting in the fusion of two helium nuclei. After that, an alpha particle forms containing the energetic release of two protons, which finally completes the process. Helium fusion is also called the triple alpha process. It is a nuclear reaction of three helium-4 nuclei being transformed into carbon. This process happens after the proton-proton reaction. The carbon fusion cycle occurs in stars with central temperatures greater than 15 million Kelvin. The main thing that this cycle focuses on is the adding of protons. Sirius gets almost all of its energy from the cycle. Stellar nucleosynthesis is a process by which elements are created within stars by combining the protons and neutrons together from the nucleus of a lighter element. It takes almost 10 million years for a star to burn through all of its helium, but when it does, it needs to create larger elements in order for its energy to be sustained. Chemical reactions do not occur in stars due to the intense pressure and high temperatures. They are too sensitive. Most of the stars you see at night are more than 1,000 times farther away from us than the sun. Some stars are so far away that it can take hundreds or even thousands of years for their light to even reach Earth's atmosphere. To put that in perspective, the distance traveled by light is called a light year, that's a very long number that I cannot say. I don't even know what that is. Stars do not actually twinkle. When the light enters Earth's atmosphere, it is bounced around by the particles in the air, causing the stars to appear like they do. This is scientifically known as stellar scintillation. How are stars important to our life? And here is a quote from Lawrence Krauss. "You are all stardust. You couldn't be here if stars hadn't exploded, because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution and for life, weren't created at the beginning of the time. They were created in the nuclear furnaces of stars, and the only way for them to get into your body is if those stars were kind enough to explode." Stars last a very long time, but when they run out of fuel, they start to collapse under their own gravity until eventually they explode in what is known as a supernova. It takes millions of years for this to occur because of the intense nuclear reactions that go on inside a star. Practically, it has to melt and run out of every element available before it can meet its death. When it goes through this process, its outer layers are blown out into space, which takes approximately 2 years. That is all.